then the cone structure will give us ideas, like as in suppose we have this cone structure, and this cone structure, if you cut in different sections, you will get different types of uh, structures, or like conic sections rather. Okay, so let us see the different type of conic sections. So if we cut the cone in such a manner that it is a section plane through the apex, then we get the triangle structure. Okay, so these are called the generators. So if you're using the section plane in such a manner that it is cutting both the generators, you will get an ellipse, right? That is, the shape of the section surface will be an ellipse. If you are using a section line parallel to any of the generator, you will get a parabola in the section surface. In case it is perpendicular to the base and parallel to the axis of the cone, you will get a hyperbola that will be generated. So these were all about the cones. Again, there is one more thing that is possible. If you section the cone with a section plane parallel to the base and perpendicular to the axis, then you will get a circle. That is another section surface or conic section that can be generated. If in case we are sectioning a cylinder through the generators, we are generating an ellipse. And if we are generating, we are sectioning a pyramid, okay, a square pyramid, we can get a trapezium kind of surface. So next is very important, that is method of hatching. Why hatching is required? When we are sectioning any part, that means that surface was not supposed to be seen from outside. So we have cut the solid, and that is the interior part of the solid. So we need to do the hatching. So for hatching, we need to use the very light 2H pencil, and the lines should be parallel and equidistant to each other at an angle of 45 degree with the reference line. I'll tell you while we are drawing, I'll tell you what reference line you will be taking. So if you see that the different methods of hatching, okay, so this one is the correct method of hatching, this is the incorrect method of hatching, okay, and these are the other methods, like these lines are not equidistant, these are very thick, okay, and again these are not proper lines. You have to draw the lines using your skill, okay. It will be recommended if you use your set square or drafter to draw this. Now, suppose we are sectioning a square pyramid with an inclined auxiliary plane. So now this is what the true shape of the section will be. So what we will do is we'll take a plane which is parallel to the section plane or section surface, and on that plane we'll get the true shape. So this is, as you can see, is the vertical plane, this is a horizontal plane, and there's a pyramid which is placed on it, and we are using a section plane on the section plane is used to cut this solid surface, okay. And as you get this surface, so you can take a parallel surface, okay, which is auxiliary reference plane. So taking this as the reference, you can draw the true shape of the section. So if we come to the first question of your assignment number 3, okay, that is your first question says a square pyramid of base 40 millimeter side and axis 65 millimeter long has its base on the horizontal plane and all the edges of the base equally inclined to the vertical plane. It is cut by the section plane perpendicular to VP. So section plane here is perpendicular to the vertical plane and inclined at 45 degree to the horizontal plane. And also it is required that where exactly the section plane lies. So it's mentioned that it is bisecting the axis. So let us see how it will look like if we draw the top view, sectional side view, and true shape of this section. So first we have to draw the XY reference line, right? Now it is said the square pyramid the base of the square pyramid is 40 and the axis is 65 millimeter long, right? So let us see. So what we have done is we have drawn the square pyramid in such a manner that it is, this is the orientation of the square pyramid and this is the top view of the square pyramid, right? So as you can see from the top, the pyramid looks something like this. And this is the apex of this pyramid. So we have to do the numbering or naming for each point A, B, C, and D, right? Accordingly, once we get the top view, we have to project this top view above the reference line so that we can get the front view. So what we will be doing is we'll be projecting all the lines above the reference line, not all the lines basically, only the line which is your central axis line above the reference line and all the lines till the reference line. So let us see how it will look like. So this is the line. So the light lines, white lines we can see here are the construction lines. So they will be lighter. Okay. And you have to draw it with the 2H pencil. Now I have drawn a line above the reference line to a height of 65 millimeter long, which has been mentioned in the question. Now from these points, I'll join till the apex. So this is the front view of the square pyramid which has been generated. Now I will name the points accordingly. So corresponding to the point A, I will get the point A dash. Corresponding to point B, I will get B dash. Corresponding to point C, I will get C dash. And corresponding to D, I will get D dash. Corresponding to O, I will get O dash. So this is my complete diagram of the orthographic projection that I have drawn for the square pyramid in this manner. Now it is time to find out where exactly the section plane lies. So as it is said that the section plane is bisecting the axis. So what I will do is I will bisect this line O dash and B dash or O dash and C dash. So this is the line, this is the point where it is bisecting. On that point, I will draw a line which is 45 degree with the reference line. I'll repeat this. I'll draw a line which is 45 degree with the reference line from that point. And this line, as you can see, is in such drawn in such a manner. It looks something like a center line. The only difference is the ends of the line which is coming out of the diagram should be solid. So this is the difference between the center line and the section line. Okay, so this is what the section line we have got. Now as you can see, the section line has cut the line O dash A dash at some point. So this point we are considering and we are taking a projection of this point on the top view, right? Again, we are marking this point. Next, O dash C dash is being cut at this point and we are taking a projection on the line OC. So this O dash A dash previously we are cutting and we are taking a projection on OA. O dash C dash we are cutting, we are taking a projection on OC. So these 2 points we have got, right? Now, what about this B dash and D dash? Because this line, we cannot take a projection because it coincides with each other, right? We cannot cut. We know that there is a cut line, but it is coinciding. So what we'll do is, we'll take the radius here, okay? We'll take the radius here and whatever is the dimension, we'll put the compass here at O on the top view, okay? And we will draw an arc on OD and OB so that we get 2 points, OD and OB. Now we have got 4 points here. This pyramid has 4 edges, okay, and the section plane has cut this pyramid on the 4 edges. These 4 points I have got. So what I need to do is I need to just join these 4 dots. So when you cut the pyramid in this manner and you look at the pyramid from the top, this is what you are going to see. Now this portion is your sectioned portion. So hatching is very much important. You have to do the hatching. Okay. So object outline has been drawn and we have to complete this drawing. So number 1, number 2 corresponding to A is 1, corresponding to B is 2, corresponding to C is 3 and 4 for D. Okay. So similarly, you name the section line, or we can say we can name the points on the front view correspondingly 1 dash, 2 dash, 3 dash and 4 dash correspondingly, right? Is it clear? Fine. And now we are doing the object outline. So this is how it is going to be. Next, what we are going to do is the true shape. Okay. So when you see this section surface, okay, perpendicularly, that means this is the direction from which you are going to see, right? So I'll draw an arrow to show this is the direction from which you are going to see, that is the direction perpendicular to this section plane. Okay, so if we see it from this side, what we are going to get is we have to draw lines perpendicular to this point. And till what distance you have to draw? That is, you have to find the distance from the reference line to 1, right? From the reference line to 1, you have to find the distance and then you have to draw the line. So the red line is corresponding to this distance. Similarly, so this is shown. Okay, I'm pointing at as 1, 1. Similarly, from the point 2, or here it is taken as 0.4 by the blue line. So I'll take this distance, and this from the reference line to the 0.4, we are taking it as the 4, 1. Okay. Again, with the green line from the reference line till 2. So from this point on the section line, I'll take the green line and I will mark 2, 1. And finally, for 3, the last red line is showing the distance from the reference line till the 3 point, and from this reference line I am taking the line perpendicular, and this is what we are getting. Now I have got again 4 points. I'll try to join these 4 points, right? In case you have any doubt, what I'll do is I'll record this video and I'll upload it in the YouTube, and I'll share the link with you. You can go through the link later on. Okay. So now the hatching is very important. As you can see, 45 degree. Now you will say, sir, how come this be 45 degree? Because this is the reference line and this is, it seems to be 90 degree, isn't it? However, for this case, this will be the reference, the section line will be the reference line. So if you consider reference line as a section line, you will see that it is 45 degree to the reference line. Okay. And definitely when you are drawing the section, the hatching, this is not how it should look like. It should be parallel lines equidistant to each other. There will be no shading, right? As I showed you, this is just for your demonstration purpose so that you can understand. Okay. Again, you can see the hatching is done on the top view, which is 45 degree to the reference line. And this reference line is the XY line. Next, we have to move towards the side view. Okay, sectional side view. So we have got the sectional top view and the true shape. Now let us come to the side view. For side view, we have to project all the lines from A, B, C, and D on this X1, Y1 line. Right, now we are going to draw the side view on the profile plane. So corresponding to D, we are getting a point D double dash. Corresponding to C, or A and C is coinciding, so A double dash and C double dash. And corresponding to point B, we are getting B double dash. How we are getting this point is, we are projecting this line till the XY line and putting the compass at this point, taking this length, we are just rotating this. Okay, so this distance from this X1, from this, just give me a minute. So from this point till this point, if I can say, so you take this distance and you just rotate it, you will get the AC. Similarly for all other lines. Okay. Now, the next thing that we are coming up with is the line part, which is your axis line. So the axis line will be the AC line here, because we are looking at the diagram from this side, right? So this is what we are going to see. So this A and this C, this is what we are going to see. So we are going to draw this line, and the height of this line will be, we'll get it from the front view. We know it is 65, still we can project it from the front view, and that will be O double dash. So we don't really need to do any kind of measurements while we are drawing the side view. We can get all the measurements from the top view and also the front view, right? Similarly, you join till the apex. Now just see this point 3 dash, when you see it from this side, it will come at the center, right? So I'll mark this point as 3 double dash. This 2 and 2 dash and 4 dash will reach at two ends. So this will become my 2 dash. Why this is 2 dash? Because this is 2. So corresponding to this, as you can see, this 2 is on the O dash B. So O dash B, this line, O double dash B. So this is the 2 point, right? Because you may get confused which one is 2, because it is not clear, they both are coinciding. So you have to find out from here. Since O dash B dash, or OB is the line, so this line is again O double dash B dash. So 2 lies here, so 2 should lie here, right? So 4 for O double dash D dash. And finally, if you project this 1 dash, you will get 1 double dash, and that will again come at the center, as you can see from this side. Now you got 4 points, you just need to join them, complete the drawing, right? This is the center line, and you complete the hatching, right? Okay. So this was the entire diagram. Now please try to draw it when I will show you on in the when you will see this in the YouTube later on. You will be able to do a recap, and you will be able to draw it by your own. Okay. In case you face any issues, you can send your queries through the WhatsApp. Okay, or you can call us for your any kind of doubt, right? However, I don't think you will face any kind of doubt, because everything is already being cleared in the video. Next question, if you see in your assignment, okay, that is question number 3 will be discussed here. The cylinder of 40 millimeter dia, 60 mm height, and having its axis vertical, it is cut by a section plane perpendicular to the vertical plane, inclined at 45 degree. 2 HP, and intersecting at axis is 32 mm above the base. Draw the front view, sectional top view, sectional side view, and the true shape of the section. Okay. So if we, okay, I'll just give you some time to just give me a minute. Okay. So I have unmuted the student. In case you have any doubt, you ask. Then I'll move to the next problem. Do you have any doubt?
Sir, sir, can you please tell again how can we draw the section? Hello?
Hello. Yes.
Can you please tell again how can we draw the section line? And how
Yes.
can we get the 2 and 4 point at the center line?
Yes. So see, section line. I'll request others to please remain silent. Okay. There is a lot of noise coming up. Okay. For the section line, what you have to do is first you have to bisect. You have to read the question and you will see that you have to bisect the axis line. Right. On the axis line, you get the point, right? And then I'll quickly show you the slide.
Sir, sir, your voice is not clear.
সকালবেলা সবাই স্যারটা বুঝাচ্ছে দিয়ে একজন সিটি মেরে দিল যে আবার সাউন্ড মাইকটা অফ করে
Okay. Is it clear now? Is it clear?
Yes, sir.
Okay. What I'll do is I'll mute all of you and then I'll repeat the process. Okay.
Okay, sir.
Okay. So that it is clear. Okay. Now I believe it is clear. I'll quickly show you how to draw the section line. So see. Now you have this. I believe you will be able to draw the top view and the front view. Till this it is fine, right? Now on this line O dash B dash, you bisect this line, and as you bisect this line you will get this point which is drawn. This point will be visible to you. Okay, right? And now on this point what you do is you from this point you draw a 45-degree line with the XY line. You will get the section line, and this is how you draw the section line. That is, you use the dash dot line that is similar to that of the center line. However, the only difference is in the section line is that whenever it is coming out of the object, that line should get solid, right? That line will become solid. Okay. So I'll quickly move on to the next problem. I don't have much time left, around 9 minutes left. I'll move on to the next problem. In case the video stops, I'll request you to again join so that we can continue. And Shubhanga sir is also there. He will be clearing the doubts in case you have. Okay. Right. So this was about our first problem. Next is next we will be discussing the question number 3, and this is the question number 3. So this is for the cone. So first you read the question. This question says that a cone of base 75 millimeter dia and axis 80 millimeter long is resting on its base on the horizontal plane. It is cut by a section plane perpendicular to the vertical plane, inclined at 45 degree to the horizontal plane. Okay, I'm not going into details. Please quickly see few things which is very important here. Now, sorry, not this one. Okay. Right. So this is the cone. So first you draw the XY plane and draw the top view. Top view of the cone is a circle, and we have to divide this circle into 12 equal parts. How to divide the circle into 12 equal parts? You draw the two diameters that are perpendicular to each other and divide it into 4 parts. Okay, now you take the radius and you put the compass here and draw an arc here, right? And if you connect this arc via the center, you will get the other point. Similarly, you repeat the process. Okay, so again we have projected all the points above the reference line, and we have projected it above the reference line. What we have projected? We have projected the center line, and we will now join all the lines to the apex, right? Okay, so we have joined all the lines towards the apex, and we'll do the numbering as we have done in the previous case. Now it is said that the plane is cutting the axis at a point of 35 millimeter from the apex. So I'll measure 35 millimeter from the apex, and this is my point. So I'll draw a line, inclined line 45 degree to the horizontal plane, right? So this inclined line has been drawn to the horizontal plane, and now what I'll be doing is I will be again all the lines has been projected, as you can see. Okay, all the lines has been projected. That is, all the lines, that is O-1 is projected on O1, right? Similarly, O-2 is projected on O2. Similarly, all the lines will be projected, and for the center line, that is O-4 and 10, we have to get this radius. We'll take this radius and we'll get 2 points. Okay, again the other lines have already been projected, so you will get all the points. It is similar but a more cumbersome process than the previous one. If you follow the previous process, you will be able to get this process again. Okay, just follow the slide. Right, now what we are going to do is we are going to get a circle, means oval kind of thing or elliptical kind of thing if we join all these points. Right, now this is our sectioned top view, right? So what we are doing, we are getting the outline of this. Now if in case you want to draw the true shape, you have to project all the lines or all the points from these section plane which has been cut at a angle of 90 degree or perpendicular to this plane, this section plane, right? So again, in the similar manner, from the reference line till that point, you will take the measurement using compass, and you will take the measurement, same measurement from A dash till A1. Again, I'll repeat, from the reference line till that point A on the top view, you will take the measurement. Same measurement, we'll take it from A dash on this perpendicular and we'll mark A1. So same process will continue to get all the other points. So this is shown incorrect. This will be KL. This will be L1, because as you can see that reference line to B distance is less. How it can be that much? So this is not the correct distance. That should be corrected. I'll correct it later on. Okay. However, I'm telling it telling you please check this. Okay, this reference line to the L line has been marked as B1 here. So similarly, I'll get all the other points in this manner. And if I join all these points, I'll get this entire true shape, right? Okay. So after I get this, again, I have to project for the side view. Okay. Please don't mark on the slide. I'll request you, we'll again repeat this process. Okay. Please wait. We don't have much time. 2 minutes are left. Okay. Now, for the side view, I'll just rotate this and I will get the side view similar to the previous case. So I'll take the projections of all the points and see, as we can see that from your from this side, if you see, okay, this point A dash will come at the center, right? A dash will come at the center. Similarly, B dash will move to some side, right? Which side? Again, you follow the same process as we have done in the previous case. So this is how we are going to get all the points. And now if you mark all the points and join them, you will get the exact shape. After you complete the drawing, you complete the hatching and you will get the exact diagram. So this is your complete drawing. We don't have much time. I'll stop the video here. We'll quickly try to connect again. I'll share you another link because we have some time left, right? So I'll stop the sharing here. I believe all of you were able to follow. Okay.
Yes, sir.
Yes, sir.
All right.
Yes, sir.
In case you have any doubt, I'll upload this in the YouTube and share the link with you. Okay. And there will be another meeting will held shortly. Okay. Another link will be shared with you. Subhankar sir will be describing you the second problem.